Okay, we're going to start series, but first we're going to go over some different notation, factorial notation. N factorial is the product of consecutive numbers leading up to n. Unless you have 0 factorial, then you just have 1. Just an example, 6 factorial would be 1 times 2 times 3 times 4 times 5 times 6. And you would multiply all that together. 3 factorial would be just 1 times 2 times 3, which is easier, which would be 6. So write the first 5 terms of the sequence given, and now it's giving you a little factorial notation. So if I'm trying to write the first term, this would be 3 to the 1 plus 1 over 1 factorial. So that's 4 over, well, 1 only gets to 1, so 4. A sub 2, 3 to the second power, plus 1 over 2 factorial. Be 9 plus 1 is 10 over 2 times 1 would be 5. A sub 3, 3 cubed, plus 1 over 3 factorial. 27 to be 28 over, we already did that above, would to be 6. Reduce them both by 2. 14 thirds. A to the fourth, 3, or a sub 4 fourth term, 3 to the fourth plus 1 over 4 factorial would be 3 to the fourth is 81 plus 1 would be 82. 4 factorial, 1, 2, 3, 4, so that'd be 1 times 2 is 2, times 3 is 6, times 4 is 24. Reducible by 2, 41 over 12. Fifth term, 3 to the fifth power plus 1 over 5 factorial. 3 to the fifth, 243 plus 1 would be 244. 5 factorial, what do we say this was? 24 right here. So we need to do 24 times 5 would be 120. Reduce them by 2. What would this be? 122 over 60. So we can go by 2 again. Over 30. Reduce that by 2 would be 61. Simplifying factorials. Okay, I'm going to write out this one, and then we should catch on to the pattern. 9 factorial will be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 3 factorial is just going to give me 3 times 2 times 1. 7 factorial, 7 times 6, 5, 4, 3, 2, 1. Simplifying factorials is wanting you to pick out this. All of this part right here is the same. Can cancel out with each other. 9 times 8 would be 72 over 6, which would be 12. Okay, simplify 3 factorial, 8 factorial over 4 factorial, 4 factorial. So my 3 factorial is going to be 3, 2, 1, and my first 4 factorial is 4, 3, 2, 1. So these are all going to cancel. 8 factorial, 8, 7, 6, 5, 4, 3, 2, 1 over 4, 3, 2, 1, 4, 3, 2, 1, 4, 3, 2, 1. 8 times 7 times 6 times 5 gives me 1,680 divided by 4 gives me 420. Okay, how would this end up? Well, if I start least to greatest, I would go 1 times 2 times 3 times all the way up to n, and then my next term would be n plus 1. Over on the bottom would be 1 times 2 times 3 all the way up to n. So all of this is going to cancel, and I'm only going to be left with n plus 1. So what starts out as looking very complicated and very long ends up not. Okay, summation notation. This is telling us we're taking the sum from term 1 to term 4, and this is our pattern. So term 1 would be 4 times 1 plus 1 would be 5. Term 2, 4 times 2 plus 1, 9. 4 times 3 plus 1, 13. And 4 times 4 plus 1, 17. Add all those up. Our summation notation equals, or it isn't summation notation, this sum is 5 plus 9 plus 13 plus 17, 44. Try this next one, see if you can do it on your own. This time we're going from the second term to the fifth term, bottom to the top. So 2 plus k, or I'm sorry, k would have been, is what we're substituting in. So 2 plus 2 cubed plus 2 plus 3 cubed plus 2 plus 4 cubed plus 2 plus 5 cubed. Sometimes writing it out like this, you can see a pattern easier. 2 plus 2 plus 2 plus 2 is going to be 8, plus 2 cubed is 8, 3 cubed is 27, 4 cubed, 64, 5 cubed is 125. Add it all up. 64 plus 27 plus 8 gives me 232. Okay, summation notation with a factorial. I've got to go from term 1 to term 6. So that's 2 over 1 factorial, 2 over 2 factorial, 2 over 3 factorial, 2 over 4 factorial, 2 over 5 factorial, and 2 over 6 factorial. We know 1 factorial is 1, so that's 2. 2 factorial is 2, so that's 1. 3 factorial, I think we said that was 6, so there's 1/3. If that was 6 times 4 would be 2 over 24 would be 1/12. If that's 24, 24 times 5 would be 120. So that'd be 1 over 60. Oops, that's a plus sign. And 120 times 6, just going one step further, would be 126. And that would be 1 over 63. Adding these up gives us, and this one we have to round, 3.449. Okay, it's called a partial sum if you are only summing up so many terms. It's called an infinite sum if you are adding up all the way to infinity. Pretty easy to remember. Find the third partial sum. So I want to go 3 terms into this. So my first one will be 5 over 10 to the 1. This tells me where to start. 5 over 10 to the 2, and 5 over 10 to the 3. You are allowed calculators on this, so please use them. 5 over 10 plus 5 over 100 plus 5 over 1,000 would be 0.555. Find the sum. Well, we can easily see the pattern here. What are the decimals? Because when you're trying to find a infinite sum, a lot of times you have a repeating decimal. Well, 5 divided by 10, that gives us 0.5. 5 divided by 100, that gives us 0.05. And 5 divided by 1,000 was 0.005. So this pattern is going to continue, and I'm going to keep on tacking on 5s. This leads us to the repeating decimal of 0.5 repeating. I'm just going to get a list of 0.5555555.